Good morning, this August gathering in this day. I take my lead from the Air Chief Marshal's statement. Typically, we take days together to identify the target, and then after working a couple of days, we identify 6 or 7 targets to go and bombard. So from this perspective, my entire today's talk is going to be about how quickly, how efficiently I can identify the target so that I can pass on to the concerned team so that they can able to carry out their actions efficiently. So basically, if you see, the entire thing percolates down to the battlefield awareness, where I would prefer to have real-time 360-degree about the operational environment. I want to know entire thing about the space, battle space, where I'm going to interact and going to deliver my actions. So obviously, as you are aware, it requires the perceptions, which includes the terrain, installations, as well as the infrastructures and range and capacity of the weaponaries being used by the adversaries. And all this information basically comes from different sources of intelligences, whether it is image intelligence or the signal intelligence or even the tech intelligence. It varies from different directions, from different dimensions. Ultimately, if you see in the contemporary time frame, most of these informations or the intelligence are geotagged. What do you mean by the geotagged? It has a X, Y, Z, the locations, the latitude, longitude, and then the elevations. In addition to that, in the contemporary time, let me say the past 10 years or so, things have become the autonomous systems. Now, in addition to the X, Y, and Z, the time component also be there, because the formations, the swarms, they keep changing very quickly, very rapidly. So the present generation intelligence also need to be time resolved, not only X, Y, and Z resolved. So once if I have the reasonably X, Y, Z and time resolved information, I need to comprehend so that the information is transformed into knowledge and then passed on for me to take further actions or further projections. So in this particular context, I will say that the GeoInt is the most significant aspect of the present day warfare in integrating all the intelligence information into the spatial coordinates, into the time coordinates, and then perceive my threats, perceive my ranges, perceive the assets, whatever my adversaries are having. So obviously, the first further dimension to the present generation and then futuristic generation warfare is more of information and perception, and with some mixture of kinetic as well as the non-kinetic actions. So by and large, even yesterday, Air Vice Marshal Court also speaking about, and today also the Air Vice Marshal is speaking about, it is more going to be the cognitive way of warfare than that of the kinetic way. It means the progressively it is more into the cognitive way of warfare that is prevailing in the present as well as in the futuristic trend of warfares. So I need to have, to dominate, I need to have complete information dominance of everything about my adversaries. That is the only way for me to have the complete domination about my adversaries. So the autonomous systems and efficient decision making integrated knowledge processing tools, this is again very new in the last decade or so. Previously, whatever we do, the sequential, now they all become autonomous, and then as well as the integrated processing way of approach, it has again revolutionized in bringing out there is no false alarm. It means, can I able to, as the predecessor told, there is no Murphy's law in the case of warfare. So can I able to have absolutely get an information without any false alarm? That is the way we are heading towards. So all the above things, the point I mentioned about, it requires very precise information transformed into superior knowledge, and then effective decision making, wherein the AI and ML plays in the contemporary times very important and a very pivotal role. So why, again, I want to give you the emphasis towards the contemporary warfare. As I've been, since yesterday morning, I'm hearing it is emphasized that especially the Russia-Ukraine war, as well as the Israel-Hamas or the Gaza Strip, All the things comes down to the changing warfare scenarios. So that the dynamics, what we thought that 2 decades back, it means a large aircraft carrier, large submarines, large, all these large things has now been questioned by small autonomous, whether it is drones or whether it is underwater or it is surface water or autonomous ground vehicles. So now one is the small things is threatening the bigger things, because the maneuverability of the bigger thing is very difficult, as well as the cost involved in making the bigger things are very difficult. Finally, if it is vulnerable to the smaller things, and that also in the form of a swarm. It means you can even see that many times the American Navy is perplexed with a swarm of drones moving around their warships. It means one warship, the present generation, it is mainly kamikaze drones or loitering munitions. So one by one, if the 10 comes, even the big warship will not able to handle. So they can first jam the communication devices, then one by one their completely entire aircraft carrier can be disabled, or they may not be able to perform its role. So now there is a paradigm shift from bigger to now the more smaller, autonomous, independent, and then whether you can put it into swarm based of approaches. So that's why even if you see the Russian Ukraine war, they have used the drone, but still they are not gone into the phase of the swarm concept. So, but it is not too late. We will be getting, it is expected in case if the war continues, the swarm concept, it is going to be definitely come in the, even if we can see in the Russian-Ukraine battlefield by 2025, it is expected. And coming to our own adversaries in our backyard, recently it has come in the newspaper that they have conducted the military drills near the line of actual control. So obviously it comes to, it is highlighted, they have got a lot of technologically advanced, weaponaries and then systems into this drill. So now it is very pertinent for me to know individual assets, what are all the assets they have used, what are all their capabilities, and what is the range to which it can attack or it can affect me further. So putting all this information into consideration, now I need to have complete information dominance to know my adversaries, and then only I will be able to dominate. So now if I want to put across what the GeoInt can do, put together all this in case of the information dominance. So it can start from very simplistic, the data acquisition. So all of you also must be frequently seeing in your newspaper as well as in the TV news channels, Chinese ships are moving in Indian Ocean region frequently, and then what for? They are basically what to find out, not one is to find out our missile trajectories, and also for the underwater information, the bathymetry related informations of the places where they can reach, because typically it is considered southern part, the peninsular part of India is safer, but now if you have your maritime advantages, it is even that part of India cannot be. That's why they have made the garland. So the one thing is getting the geospatial information, and second thing is the analytics, the data analytics of this particular huge voluminous database, whatever you are going to generate. And then comes the entire domain of the feature extraction, the target recognition, and then the scene description, and finally, as some time back Dr. Pinaki also mentioned, the mobility, whether in which kind of, it is not necessarily only for the army or the tank, kind of vehicles, even for your amphibious kind of warfare if you want to do, or if you are interested in near coastal kind of environment. So it is very important to have the GeoInt into action. Globally, there are both Australia, UK, USA, and then in India, DIPAC, DGRE, and NTRO into this GeoInt related operations. Basically, the information has to be now coordinated in geospatial framework, and then you have to go for your further actions. So when I speak about the information gathering, till recently, let me put during 80s, if I could able to cover one of the important aspect of the identification of the target is camouflaging. I don't want to reveal my asset to my enemy. So one of the way people used to do till the 80s is you bring a material, or you may bring a net, or you bring a paint, or whatever may be, which mimics the signature of the vegetations or the ambient environment. So that if I put that kind of net, I have given a few photographs of whether it is a soldier, whether it is some kind of tank. If I put this kind of net or the material on top of it, my adversaries using the detectors, using the sensors, will not be able to detect it as a tank or my asset. Now, people worked in the 80s the visible near infrared and shortwave infrared region. So you can see the top one, I have the pointer. Okay, the top one is the grass spectra, and down the line you can see HV6, HV5, DV4, DV3. They are all synthetic materials which mimics your vegetation spectra. So this was during the 80s. And during 90s, you can see the domain went, because the tanks or most of these your vehicles or assets, it emits thermal signatures. So people migrated into the thermal domain and how to mask the signatures being given by your assets. So it moved to, for example, the CBAS satellite group, it camouflaged the particular kind of tank systems, T-72 kind of tank system. This was common during 90s. So when I speak about this signature, now I'm coming to the domain of signature. When you talk about the targets, obviously the question comes is the signature. How will you detect these targets? So the way the US, the national security has evolved from 1980s to till today, they have, Army has its own unit, Navy has its own unit, as well as the Naval has, the Air Force has its own unit. In addition to that, there are Central Command has also its own units of gathering these signature bases. Because these signature bases are very vital, because tomorrow if I want to know what kind of asset my adversaries are having, or the X, Y or Z is having, they want to have the signature bases of all the adversaries. And not only that, this is where as Dr. Air Vice Marshal Court was speaking about yesterday, they used to have the regiments with the assets. For example, if my adversary is Russian, so I will have all the the soldiers trained in the thought process of the Russian, or even the assets of Russian assets, Russian nets. So I will be, the entire war game will happen between the US Army as well as their own army only, but they will have the mindset of a Russian, how they will behave, what will be the targets of the Russian. So this is the way the conventional war games are being held in Russia, in America. And then lot of informations are being collected, whether we can detect whether it is a T-72 tanks, or whether it is T-80, or whether, so many kind of assets, whether I will be able to detect using my sensors at a given time. So this understanding is very critical. Tomorrow when you go into the real-time war with the X, Y or Z country, you need to know what are all the characteristics of their assets. Do we have the signatures, or do we have to identify and classify what kind of assets we are dealing with? So it is giving you straight away the many of the information which the different levels of information what a support to military operations requires, straight away we need to have in our packet. And coming to our adversaries. So they started reasonably during 80s. They made the wide spectral EMR informations. Basically initially started with the airborne missions and progressed, and finally they have now gone into the spaceborne missions. They have, I can say it is a huge number of assets they have in the space, which can give very rapid information and in very quick time turnover, lot of information about our assets, whatever we are having in our hands. But in coming to the point from Indian perspective, till now we do not have such a kind of satellite systems, or the airborne systems, which can able to give us the across the domain visible near infrared, shortwave infrared, and even thermal infrared. Till this date we do not have a satellite which can operate the thermal infrared system. as well as our turnaround period. For example, even in the visible and the NIR, if I speak, it take couple of days for the revisit of the satellite. So I will not able to get the time in which I need to, in battle space, I may require information for every half a day or every 2 hours or 3 hours, but now I do not have such a kind of information about my battlefield. Okay, these are all, whatever I talked is gone 10 years back, 15 years back. The scenario I told you, the target identification, what I told you now is 10 years back. Now, the vegetation looking, what are the camouflage materials are gone. Now, we have got the metamaterials as well as the semiconductor devices which can selectively emit in certain regions. What are those regions? Those regions are the regions where the electromagnetic radiation do not pass through your atmosphere. So we have totally gone into the material will be there, but you will not get any signature from the space because the atmosphere completely eats away this energy, so you will not get. So this is the domain now we are going in the recent times. And the graphene based adaptive thermal camouflage is the very recent things. The material will be there, it will be producing heat. Let me put a tank, operational tank, obviously it will produce a heat, or any vehicle it will produce heat. That heat will not be seen outside because the surface layers it handles efficiently, so the heat signatures you will not able to see from your sensors. So the takeaway point from this is now the story have gone beyond the visible NIR as well as the multispectral camouflage. I am given to understand as of today, Indian tanks, 90% of the Indian tanks have, related things have only the visible and the NIR camouflage systems that also using the jute kind of materials. Now the scenario has gone very significantly different to the metamaterials in coming to the role of camouflaging. And another is decoy. This is again I will take the example from the Russia and the Ukraine war. There has been enormous demand for the decoy. I want to put a tank looking inflatable toy in the field so that if my enemy bombards his weaponaries on that toy, I am gained because he is losing his weaponaries. This is the conventional. There is nothing very big about it. But now comes the question is, in the contemporary times, even the toys, decoys, they give the signatures of the real time or performing assets. For example, if I take a tank which is a decoy, but it is giving you the thermal signatures, it is giving you the radar reflections. So obviously the enemy will definitely be confused between a decoy with giving good amount of the signatures. So again the point I want to give out is discerning the decoy as well as the target is also becoming more and more complex. And the next aspect of the target is the standoff chemical agents. Yesterday, Professor Neeraj Kumbhakarna was speaking about the AI and ML in bringing out the new molecular compounds which doesn't give propellants, which doesn't give traces of the gases or the smokes for your missiles or related applications. So now the same way, the standoff gases, it can be a nerve agent, it can be blister agent, or it can be any kind of this damage causing gases as well as liquids, which are been even in the Ukraine-Russia war, it has been extensively used, the similar kind of chemical agents. So how to detect that? So again, there is going to be, we need to have inventory of these signatures, whether it is in vapor form, whether it is in liquid form, or whether it is in solid form. So we need to have signatures, the list of this kind of standoff gases and their signature. And this is another case where it is commonly used, the smoke candles, for you to have your manipulations during the operations. Even the smoke candles are now very well engineered. So whether you can, with your normal multispectral or sphere or the NIR detectors, you will not able to identify the object what that is being concealed. So you need to have different kind of systems to identify the object behind the smoke candles. So again, coming to the simplest point, you put the smoke and then you escape, you run away, or you move your target. That is also becoming complex because now the signatures, they have been made with the specific signatures, so the targets are becoming complex. So under these circumstances, what is the way out? So the ways are there, but the question is how we are going to collect the signatures, how we are going to compile the signatures, how we are going to, fuse these signatures or the informations and use it for our purposes. So this one particular signature, basically it speaks about the SF6 releases into the atmosphere, which can be nicely picked up from the drone-based IR, FTIR instrumentation. Even you can able to quantify how much concentration of this SF6 is coming, plumes are coming. And this is another aspect, even the Indian Navy, the tank technology people, they were talking about is, sir, we want the autonomous ground vehicles which can able to have the battlefield signatures informations, whether it is a camouflage material or whether it is a gases or any kind of these materials. So this also we need to have, again, the signature databases. The technology is available, so whether you want to operate it from the ground vehicles or whether you want to operate from the UAVs or whether you want to operate it from the space-based platforms. Yeah, this is another technological advantage or the way forward. Now, whatever I talked about is the passive way of collecting the signatures. Now, technology has further changed. So now I can shine my environment with the lasers, wavelength specific lasers, and then the following spectrometers can able to scan that particular surface, and then I will able to pick up many of the compounds which are not normally seen when you do with the passive remote sensings. So this is also coming up for many of the applications, especially for ground-based as well as drone-based applications. This can be very one potential tool to generate the signatures. It's not moving. And another important target identification is mind space detection. Again, there is a paradigm shift what happened 10 years back to the contemporary times. Typically, all the military people who are into the on the other side of the operations, they will be interested to know what are all the areas that are mined, so that the personnel as well as the tanks can be moving in the terrain safely. Till now, it has been by and large X, Y, Z. As I told you, you know the locations, find out the location where a particular anti-tank or anti-personnel mines are laid. Now, recently again the Russian-Ukraine war has revealed another very interesting thing is, the mine will not be there along the track where you are moving, where you intend to move. That space is completely clear. Mine will be placed somewhere else. As soon as your tank or your vehicle moves in the terrain, the vibrations are picked up by the acoustic sensors, and then it shoots the warhead to the surface, which goes to 50 meters above the surface. And that surface, it has radar, it has thermal sensors, it comes and hits on your tank or on your vehicles. So now, last 10 years back, it is only the case of no X, Y, Z where the landmines are placed. Now it is X, Y, Z, and in addition to that, the range of the landmine, it means it can have the range about 100 meters. That's what you are, the Hornet as well as PTKM-1 are. Hornet is American, wide area munition, whereas PTKM-1 is the Russian variant of that. It caused a lot of damages during this Ukraine war. Not only the story ends there, the present contemporary times, the drone-based delivery of that also everybody might have seen in the YouTube, the drone-aided dropping of the munitions, as well as loitering munitions. No more the explosive is going to, just if I fire it, it is going to fall on the particular trajectory. It will fly, it will take its own time, and then it will go and attack or whatever the targets that it detects based on IR sensor or whatever may be the mechanism. So now, again the point is, initially landmine detection, one single point you detect, it is there, it is there, it is there. Now it is no more. Because it has a range, it may be there, it can able to have the capacity to hit 100 meters far away. And present day times, even these landmines, it is not going to be what to say X, Y, Z and range. Now it is also can able to move in formations from camouflage. They're all camouflage mines. They can move in time domain as a formation, as a swarm. So now the more important component in landmine detection also it becomes the locations, range, as well as the time dependent target detections. So coming to the point, it is not going to be so simple. Whether it is the camouflage materials, or whether it is decoy, or whether it is the landmine, or whether it is gases, you cannot able to depend on one mechanism, one sensor way of detecting the targets. You need to have multiple way of sensors integration. Then only you will able to prevent yourself from no false alarms or absolutely finding out the targets. If this is the case, we are left with no option but with fusion of the sensor, multi-sensor or multi-images information, so that arrive at the information, the target, how quickly, how efficiently I can identify my target, so that I can pass it on. So it requires basically across the EMR spectrum detectors as well as the multi-scale. Even Dr. Pinaki was highlighting about the multi-scale, because the granularity differs when I operate from whether it is satellite or from the drones or from the ground-based sensors, the granularity differs. So now I need to have the mechanism to collect the information across the EMR spectrum, across the scale, across the platforms, and then my objectives may vary from just detection or identification or even characterization of the target. It is not just I identify, find out an anomaly and then go and hit. Many times I may also be interested to find out what is that particular target and what kind of characters, because when I want to completely understand the particular target, I need to have the characterization also. So it is very important to go for all the three aspects, not only the detection. And as I have been telling over the first few slides, we need to have a good signature collections of our adversaries, the assets of our adversaries. Sir, many times the battlefield environment, there may be a signature, the satellite may be capturing, I may not be having the drone or ground-based asset at that particular time for me to get the signature. Many times, by virtue of the altitude, by virtue of the spatial as well as the spectral resolutions of my satellite, I may able to miss that signature, because that's, as I go that when I go to the 400 or 600 kilometer orbit, the signature may be present, let me say 10 meter signature. So I may be missing, or generally it will be occurring along with the combination of other signatures present within my field of view. So under these situations, I also need to simulate if the particular signature is present in a particular environment, how it will appear in my image space, alright? So the image simulation of target as well as the environment association is also very, very necessary for both the tactical as well as the strategic applications. And then the war game. War game means it is not only my war game, I am doing around with my friendly nations. Many times the exercises being done by adversaries in their own terrain, we need to keep a tag, or we need to keep our payloads flying over that area. After all, they will not able to generate every next day new assets and new technologies. The end of the day, what they use in their exercises, they may be coming to our border at a particular point of time. So we need also to have the signature databases of the adversaries, the assets characteristics, those information also we need to compile and use it when it is needed. So I'm giving you the list of areas where it can be used, especially the signatures to find out the targets. I'm moving further. So now comes the question is the integration. Sir, what level we can go for this integration? We can go for the integration at the data level, or we can go the integration at the feature level, or we can go at decision level. So each one of them has its own benefit, or it has its own demerits. So if I go into the data level, sometimes I may need to do, but data is a huge volume, but it has wonderful information. There is no loss, because if I am fusing, let me say, visible and thermal regions, it has a lot of information unique from visible as well as the thermal. So it has its own advantages, but the main issue is the computational ability of such a huge databases. And also it is depending upon what is the level of precision I need. If it is anomaly detection only, probably I don't need to go for the data level fusion. I can go for the feature level fusion because I don't, just for me to detect only, I don't need to go for identify and characterize the target. And next important question is how quickly I want this information. Whether I want to find these details in next 1 hour, next 2 hours, or I'm having the freedom of finding out the targets in next 1 day or 48 hours. So depending upon that also, we need to converge at the image fusions or the integration levels, whether from the data level or at the feature level or at the decision level. Coming to the topology of the fusions, we can have the parallel, or we can have the serial, or the decision tree based, or the network based. So it is depending upon the complexity of identification. For example, if I'm interested in metamaterial based camouflage detection, obviously the parallel serial may fail, and I may be interested in the network based approaches to find out such a highly engineered materials which is acting as a camouflage material. And the logic for the fusion also can be, there are n number of algorithms available, right from the PCA, wavelet, or CCA, OSP, this kind of based on image detection, image cleaning. And coming to the target detection, again the deep learning or GAN based approaches, there are a number of tools available, AI and ML based tools available. We need to have a call on how efficient the combination of our fusion as well as the target detection techniques should need to handhold, so that finally the targets are identified at a lesser time, almost like real or near real time, without much failures. So the battlefield environment, the way I perceive the future is, it is going to be the integrated data analytics that is going to be from multi-sensor as well as the multi-platform that is going to be the future. Obviously, when we talk about the huge voluminous data as well as the complexities associated with it, deep learning based target fusion as well as the target detection is going to be the important area. And then high spectral resolution payloads operating from both satellites as well as high altitude pseudo satellites. This is a new area emerging up, because I'm not able to put all, if I put it into 400-kilometer orbit, I may lose the spatial and spectral resolutions. So can I able to put in alternate orbit, for example, I want to operate for 30 days, 90 days, or 2 months or 3 months, whatever may be the framework. Generally, the HAPS platforms gives you the short duration of your information, so that also can be effectively used. And constellation of satellites are needed in the contemporary time, because as I told you, as I have been emphasizing you, the things changes autonomous, when we get into the autonomous based, whether it is vehicles or whether it is even munitions moving around, the time becomes an important criteria. So for which I need to have a constellation of the targets. So let me say every 3 hours or every 4 hours, I need to get the data to know real time, or I can say the near real time battlefield environment. Yeah, thank you.